We all know that space travel is dangerous. But despite the dangers highlighted by the 2 space shuttle tragedies and all the problems that have beleaguered the International Space Station, our curiosity and desire to explore the universe is alive and well. Just witness China, Japan, and Europe's new space programs. The initial spirit of the Apollo missions of the 60s and 70s hasn't gone away. Far from it. And as I'm sure many of you have thought about, that spirit of exploration isn't just the result of romantic notions of space travel and discovering life on other planets. I hate to say it, but it reflects a growing realization that at some point in the future, and it may be closer than we think, we'll have to colonize other planets. Why? Out of necessity, because as Earth's resources run out, and if our climate continues to change, life here simply won't be sustainable. So, with that in mind, I'd like us to consider the planet Mars as a contender for a possible space colony. And I'd like to outline some of the obstacles that would need to be overcome if we're going to send astronauts to Mars to get things started. So far, only robots have been sent. I'm going to look at 3 obstacles. 1, designing and building a spacecraft that could get astronauts to Mars in one piece. 2, an effective method of propulsion. And 3, the supply of water, fuel, air, and food needed. First, let's look at the design of the spacecraft. Well, right away, scientists know that a winged aircraft like the space shuttle isn't an option. Why? Because the Martian atmosphere is just too thin. The wings wouldn't support the shuttle because they wouldn't get enough lift from the air. Result, the craft would simply plummet to the ground. Plus, even on short trips, the shuttle is beginning to look pretty unreliable. So, what's the alternative? Okay, well, it looks as though some kind of capsule, like the ones used in the Gemini and the Apollo programs, is a real possibility. These capsules prove to be strong and safe, particularly during the critical and very dangerous first and last 100 miles of space missions. In fact, work is already being done to develop a capsule-like crew transfer vehicle to carry astronauts to and from the International Space Station. Are you with me? Well, then let's move on to the second challenge, namely propulsion. You've got your spacecraft. Now, how do you power it all the way to Mars and back? Whatever power source you use, it needs to be reliable, safe, and fast. After all, the astronauts don't want to spend any longer than necessary in such a small vehicle, would you? Plus, the longer they're in deep space, the longer they're exposed to dangerous radiation. So, what are the options? Well, there are 3 options, but none are perfect. The first option is an ion propulsion engine. Now, for this kind of engine, a portable nuclear reactor heats charged gas and then fires it out of the rear of the spacecraft. That's ion propulsion. Do you know what I mean? The main advantage of this kind of engine is that it can accelerate the craft to very high speeds. The disadvantage is that it's slow to accelerate, and as we've seen, time is important and needs to be minimized on such a long journey. The second option is nuclear thermal propulsion. This kind of engine uses a nuclear reactor to heat propellant and blast it out of the engine nozzle. Are you following? Advantage, this system gets the craft moving much faster. Disadvantage, it's heavier and worries environmentalists who are concerned about a possible nuclear disaster before the rocket even leaves the atmosphere. The third possible option is a plasma propulsion rocket. Now, this kind of engine is currently being developed by NASA and can get astronauts to Mars in just 40 days. Very impressive. This system uses magnets and gas to produce acceleration. There are no obvious disadvantages, except that it will take several more years to develop. A bigger problem than either the spacecraft or propulsion method, though, is the water, fuel, air, and food a mission to Mars would require. Unlike the Apollo trips, which lasted a maximum of 12 days, a round trip to Mars would take about 14 months. You then have to add to that another 18 months on the planet itself, waiting for the next moment when the positions of the Earth and Mars would allow for a return home. So, you see, in total, a trip to Mars would take nearly 3 years. This presents a big problem for scientists who need to minimize the weight while also ensuring that the astronauts have the water, fuel, air, and food they need. And they can't simply build a larger ship to carry all the cargo, as this would require a rocket so large it would probably be impossible to launch. So, what are the alternatives? One possibility would be to manufacture a lot of what's needed on Mars itself rather than here on Earth. Detecting water on the planet in advance would be essential for this option. For starters, the water, once purified, could be used for drinking and bathing. And what's more, the hydrogen and oxygen that make up the water could be used to propel the liquid fuel engines of the ship for the return to Earth. Of course, astronauts would need to have a facility to manufacture the fuel, but assuming that that could be done, then they could fill up the fuel tanks and return home. Do you see where I'm going with this? The oxygen could also be used to create and maintain a breathable atmosphere on Mars. And the thing is, once you've come up with a solution for the water, fuel, and air problems, you've pretty much also come up with a solution to the food problem. After all, if you're able to produce these things on Mars, then throw sunlight into the mix and you've got practically all you need to grow food. So you can see that although there are plenty of ifs and buts, here's a neat solution to a number of the key problems, right? To sum up then, the goal of colonizing the red planet is almost within reach, it seems, but like I said, there are lots of ifs and buts, and it'll take time. I'd say that perhaps the greatest obstacle of all is something I haven't mentioned, and that's the political and bureaucratic one. While the technical obstacles might be overcome, I suspect that the political and bureaucratic one won't be so easy.